Now we're gonna do the final take of the Hugging Face. Because let me go back a bit into the whole AI for developers part. And now I'm enrolled into the, let's go to home. I'll register for this. First I need to I want to finish all of this. Where is my associate AI engineer for developers? So this is the track that I'm taking right now. And I'm working on this. Now I'm working with this, working with Hugging Face. So I'm gonna try to finish. Let's make a deep effort right now and try to go all in until we finish this part. And then we take a break, and because I need to do a lot of things for Play-Dohs and my business. So let's finish this. Let's go right into it. I'm just gonna check that the audio is good. Play-Dohs, and yeah, it's good. So let's go.
Welcome back. Pipelines are a fantastic way to quickly perform tasks like text classification or summarization, as we explored previously. But what if you need more control? Autoclasses are a flexible way to load models, tokenizers, and other components without manual setup. They offer more control compared to pipelines, making them ideal for advanced tasks. While pipelines are great for quick experimentation, autoclasses let us customize every step. Now that we've introduced autoclasses, let's see how they simplify working with models. To directly download a model, we import the relevant auto model class for your task. For example, in text classification, also known as sequence classification, we use auto model for sequence classification. To load the model, use the .from_pre-trained method and specify the model name. To prepare text input for use in a model, we use tokenizers. It's recommended to use the tokenizer paired with the model to ensure the input is processed exactly how it was during training. With pipelines, this tokenizer and model pairing happens automatically. However, with autoclasses, you handle this step yourself. To retrieve the tokenizer for our model, first import auto tokenizer from transformers, then call the .from_pre-trained method and pass in the model name. Tokenizers work by first cleaning the input, such as lowercasing words or removing accents, and then dividing the text into smaller chunks called tokens. In this example, we load the tokenizer paired with our model using .from_pre-trained. Then we call the .tokenize method to split the sentence into tokens. The output shows how the text is processed and broken into smaller parts that the model can understand. Different models may handle tokenization differently. While our example tokenizer processes text in a specific way, other models may produce different outputs for the same input. Now, let's create a custom pipeline. We start by importing the necessary modules, downloading a model and tokenizer, and combining them into a pipeline. By specifying the task model and tokenizer, we gain full control over the process for sentiment analysis. In a nutshell, we use auto models and auto analysis.
So just remember this: my model, tokenizer, my tokenizer. So basically, with this, we can just do more. We can have more granularity in what we input, because normally we could pass the text directly, but there is also many ways that we can tokenize, like meaning divide the text in chunks. So this is a way to do it.
In a nutshell, we use auto models and auto tokenizers instead of simple pipelines when tasks demand more control and customization. For example, advanced text preprocessing and tokenization enable cleaning tailored to specific use cases. In classification tasks, custom thresholding allows setting weights
just in case
for sentiment analysis.
Okay.
Pipelines when tasks demand processing and tokenization enable cleaning tailored to specific use cases. In classification tasks, custom thresholding allows setting weights and thresholds to prioritize categories, like assigning support more often in a customer support model. Lastly, for complex text analysis workflows involving multi-processing stages, they provide precise control to customize and integrate each step effectively. We've unlocked the power of auto models. Now, let's dive into practice.
When to use auto models and auto tokenizers. Pipelines and auto models with auto tokenizers are two approaches to working with Hugging-Face models, each suited for different use cases. Pipelines are for simplicity, while auto models and auto tokenizers provide more control and customization. Yeah. Okay. Drag each statement to the correct category. Pipelines or auto classes. I want to compare multiple models for text generation. I guess pipeline. I need a quick way to classify customer reviews or positive or negative. I guess pipeline. The task is a simple text summarization for a news article. Should put it as the origin category more. Should put it as the origin category more often. Okay, I'll take a hint because for a quick simple task, or adjusting classification threshold. Should prioritize the origin category more often. So I guess this is like a custom. And the task requires tokenization financial reports. Custom tokens for terms like. So this is like a customization. Good. Let's right into the next one. From transformers, import, I guess auto tokenizer. And then I'm gonna use this from pre-trained here, and then tokenizer will tokenize this, and it will transform this input into chunks. Like here, so that's good. So let's go and auto tokenizer. And in here, I'm gonna do this. I'm gonna. This is gonna be like pretty long, so I don't want to do that. Yeah. This is good. Then, okay, and now auto classes. You have seen how tokenizers work and explore their role in preparing text for models. Now let's take a step further by combining auto models and auto tokenizers with pipeline. So here I should do auto model. Wait. Auto model for sequence classification, and here should be auto tokenizer from pre-trained. So I should define here the model as my model and tokenizer as my, I should pass by my tokenizer and run code. Here my pipeline, and I should put this. I'm gonna create now a 10, which is 10 tokenizer. No, this is not the auto, this is auto model. So auto model. Invalid syntax. Why? Okay, maybe I'll reload the page because maybe there's something about that. Name output is not defined, but how come? The output is here. So maybe it's a runtime error. This goes pretty good. The class positive, display word, take hint. Yeah, that's good. So in the auto model, I'll do this, and I think I need to import from transformers. I need to import the auto tokenizer and auto model. Nice. Document Q&A.
Welcome back. In this video, we'll explore question answering models and use them to have conversations with documents. Let's dive in. Document question answering, or document QA, involves generating answers to questions about the contents of a document or text passage. This task requires two inputs: a document, typically a PDF file, and a question. The document could be a research paper, contract, user manual, or similar text-based file. The question is a text string asking something specific, like what is the total revenue of Q3? The answer is generated by analyzing the content and can be a direct quote or a paraphrased response. Document QA is widely used to automate data extraction and analysis across industries. In the legal sector, it identifies clauses in contracts such as termination terms. In finance, it extracts key figures like revenue and expenses from reports. In customer support, it retrieves answers to common questions from manuals or FAQs. Next, let's introduce our case study. Imagine you're an ML engineer at a large company. Your HR team is overwhelmed with questions about holidays, notice periods, and other policies. This information is stored in a multi-page document called US employee_policy.pdf, making it time-consuming to find answers manually. Using Hugging Face, we'll build a system to retrieve specific answers from the document, saving HR hours and streamlining employee communication. To start, we'll load the PDF file using the lightweight PyPDF library and its PDF reader function. We load the file by specifying the path, US_employee_policy.pdf, and use the .pages attribute to access all pages. Using a loop, we iterate through each page and call the .extract_text method to extract its contents. The text from all pages is appended to a variable, combining them into a single string and preparing the PDF for processing. Now, let's move on to creating our Q&A pipeline. For this, we've selected the question answering task with the Distilbert-base model, a lightweight and efficient choice for Q&A tasks. We crafted a question and passed it to the pipeline, along with the extracted text as the context parameter. The pipeline returned the correct answer. 1. Confirming the policy allows 1 volunteer day annually. In this video, we've combined all the pieces to automate document question answering. Using PDF Reader from PyPDF, we extracted text from the PDF document by iterating through .pages and using .extract_text to create the document.
Wait, I'm gonna just check back the code on how. Yes, so I just use the library to read.
Using PDF Reader from PyPDF, we extract .extract_text to create the document_text. Next, we set up a pipeline with task equals question answering, passed a question, and provided the extracted text as the context. The result, accurate answers to specific questions from the document. Finally, as a next step, we can wrap this pipeline into reusable functions, allowing users to ask the questions directly, saving HR time to focus on building an amazing company culture. We've covered so much. Time to put it into practice. Keep moving forward.
Got it. Okay, what task fits this scenario? We have explored core tasks like text classification, summarization, and question answering, all powered by Hugging Face pipelines. Each task has a unique application. Whether it's categorization emotions, summarizing and contents, frame precise answers to questions. In this exercise, it's your turn to assign the right task to each real-world scenario. Okay, locate total revenue for Q3 from a financial report. This is a question answering task because first you will need to have access to the financial report. Create a brief review of a 10-page financial report for busy executives. So this is a summarization task. Label new articles as politics, sport, technologies, classification. Evaluate social media posts for positivity or negativity. This is text classification. Find a maternity leave policy details for a company from a company document. It's question answering. Terminate the contract into a short list of key clauses for client understanding. Okay. Submit. From PyPDF. Okay, I need to remember PDF reader. So I need to call the PDF reader and I'm gonna import this US employee. Then the document text. Okay, so I define as an entry from reader pages. So I'm gonna call this function page, and then extract text is gonna be, and I'm gonna append all into the. So this is just a code to extract the PDF. So I'm just gonna create another file. It's gonna be 11 extracting PDF info. And this I'm gonna run because I will need to install probably the library here. So it's clear. For this file, can you please create a sample? The sample PDF needed. And okay, let's see how it rolls. Meanwhile, I think if I run this code, it should be all right. Virtual list. But here it was like, because this is not a function. This is just an object, it's a property. Okay, now it works. So here is not a function or a method. So if I run, it's now okay. If I submit the answer, now it's perfect. I'm gonna do the next exercise too. Meanwhile it's installing, and there's gonna be Q&A pipeline. This Q&A pipeline. Good. And I'm gonna keep doing this because now I'm gonna read the PDF, but I need to add this. Oh, I see that in this file I also was missing the pipeline. Okay, so here I'm gonna complete this by importing the pipeline, and here, because this is a pipeline, we need now to import a pipeline. And well, in this task, this should be question answering. We're gonna use this model. This is the question. The context is already in the document text, which is something that I was reading, I was reading in the previous question. The question is this question. The result should be result, and I want to know like, okay, this is the properties answer. So if I run the code, should be alright now. It's too weak. So in this I already read, and here I'm doing the second part, which is the Q&A pipeline. Yes, and I'm not gonna run this because probably this is gonna be like a lot of it's gonna be heavy. Also in this one, I'm gonna do no. Tell me the command to install for the current user. I'm just gonna run the file 11 because the file 12 will involve me to download the library, and I don't wanna download the model, and I don't want to do that. So first I'm gonna install PyPDF, which is gonna be here. Then Cloud generated me this whole PDF file. Probably if I open it here, it's gonna be readable. Nice. And meanwhile I'm waiting for this to install. Then I'm gonna go here. So this is good. I'm gonna submit it, and it's perfect. And now I'm gonna run the file 11 as I mentioned. Virtual list, is because the pages is not, I didn't save it. So here's the text of the whole PDF. So it's good. And now we finish the course of working with Hugging Face. I think we have basic knowledge of it. 11 files of scripts. Let's see what
Amazing
it says.
work. You've completed the Hugging Face course and taken a big step in your AI journey. Let's take a moment to celebrate everything you've learned. In Chapter 1, you explored the Hugging Face Hub, a central platform for discovering and sharing AI models and datasets. In Chapter 2, you took your skills to the next level by building Hugging Face pipelines. You explored text classification, enabling sentiment analysis, grammar checks, and dynamic category assignment. By specifying task equals text classification in a pipeline, models provide clear outputs like labels or categories with confidence scores. Text summarization reduces lengthy content into concise summaries, making it easier to digest and act upon. It is ideal for summarizing news articles, legal documents, or financial reports. To implement this, specify the summarization task in the pipeline function. You also used parameters to control the output, like tailoring it to your needs. The final task we explored was document Q&A, enabling accurate answer extraction from PDF files using the .pages and .extract text methods from the PyPDF library. This approach is ideal for analyzing long documents. To implement this, specify the question answering task in the pipeline function and retrieve answers from lengthy documents within seconds. We also covered auto models and tokenizers, essential for tasks requiring extra customization, offering precise control over inputs, outputs, and advanced workflows. Thank you for being a part of this journey. You've gained valuable skills, and this is just the beginning of your Hugging Face adventure.
You got it.
Amazing work. You've completed the Hugging Face course and taken a big step in your AI journey.
Perfect.
Let's take a moment to celebrate everything you've learned. In Chapter 1, you explored the Hugging Face Hub, a central platform for discussion.
Okay. Now I finished this. I finished the chapter of working with Hugging Face. And now we are gonna jump into our we're gonna go first to our home to check what is left. So this is our 4th day of becoming an AI engineer, and now we finish our 3rd course. Yeah, we finished this. The first day we had some issues like completing because the scripts were not running, but we finished anyway, and we have the files here in the first folder. And now today we finish with working with Hugging Face. So tomorrow, which is the last day of the week for everyone, but not for me, because I'm gonna keep working every day until Sunday, until I finish like a lot of things here. But tomorrow we're gonna continue with LLM concepts, LLM ops. So he's taking this into deployment, just to make a quick review. I'm gonna ask, what is LLM ops? Production. Okay, so it's like DevOps, but instead of Dev is ML. LLM, sorry. Versioning prompts, tracking which prompt processes which outputs, prompts are effective coding LLM ops, so they need, okay. Evaluation, cost and latency, catching responses, tracking content, choosing the right model, rack pipelines, input output filtering, from injection defense, PI. Okay, and after that, well, we have this developing AI systems with OpenAI, again with OpenAI API, and then embeddings, Pinecone. It's pretty complete. So yeah, guys, I'm just gonna push this. Here I have okay, better git log. gonna be I'm trying to paste, but it doesn't allow me. Okay, so I'm just gonna, oh, actually it's frozen. Anyway, I'm gonna push it in private when it like unfreezes, and see you tomorrow, I guess. I'm gonna do some other stuff now today.